All right, I think we're ready. A couple of things before we start today about the course. Um, One is, well, let's go to the Moodle page. There we go. It's getting close to time to turn in the assignments here. So um, there are quite a few of the benchies. I haven't gotten to grade any of those yet. We're in the middle of ABET, so this week should hopefully end that workload so that we can get over here to grade some of these things. But I just wanted you to be aware that it's getting kind of close to the end. Most of these, there were some questions about how they're graded. The benchy, so the one I called the perfect print, that one is one that I will actually go in. Now it's going to be tough to grade because you have to turn in pictures versus me having the actual benchy you printed. But I will go in and grade those as like on a scale of, well, not 0, but I guess if you turn nothing in, 0 to 100. The others, though, the calibration test, these three, the goal isn't necessarily to make a perfect print on those. These three, the retraction, temperature, and tolerance, are really just for you to know how these things work. So if you print the tolerance test, for example, and you can only get one of the little dials to free up, that's still okay as far as the course goes. It just gives you a tool to use if you want to get your printer better calibrated. So don't think you have to create these three calibration tests perfectly to get a perfect grade on them. Really, all you have to do is print them and show that you went through the process of printing them and kind of understand what they're doing. Dogs are barking. And that'll be good for the course. Now, if you want your printer to work better, then yes, work with them, tuning everything, and that's good. But you don't have to spend days or whatever trying to get a perfect tolerance test, or particularly the retraction on the one that I have linked. It's almost impossible, not impossible, but it's very, very hard to get it perfect because of the way it's shaped. These option 1 through 4 are similar. You notice if you read the syllabus, there's detailed descriptions of what the different things could be. They're optional, so you get to pick which one you want to do. And they have a grading system where 30% of it is, I think I put quality is the measure, so it's kind of subjective. Really, all that is it may be a better word instead of quality would be effort. So did you put effort into these to try to make them nice and not just throw something together really quick? Now, a lot of these, they're going to be something you downloaded off the internet and printed just to show that your printer is capable of that, and that's okay. I'm thinking, so like the maker coin, I don't want a literal cylinder and that's it. Like you went in Tinkercad and extruded a little cylinder and that was all your maker coin. That would be low effort to me. So the ones that require you to do some, or painting, there's one where you have to paint the model and you just spray paint it and that's it. That's probably not what I'm looking for, and those are going to be on the low effort side. But generally, assuming you do the thing and it looks reasonable, and it's an entire print, I think the 70% is just having the print in its entirety, then that is kind of what I'm looking for. It's more an effort thing. Did you put some effort into it, or did you just kind of do the minimum possible to get the print to print? Some of them, that may be all that it is. It literally is printing something at high resolution. So then the effort is, do you have your printer set up where it can survive a long print and print well? So that's the effort, is on the front end of it. This option 5, don't forget about that one, because that one is a longer process. It's not a print necessarily. I think I have 3 things listed there for what you could do for option 5, and it is a longer process, so don't put that one off. Looks like one person has submitted it so far, so don't wait too much on that one because it could take you longer to do. So I just wanted to update on that before we got in too far into what we're going to do today. So today, I put it down as resin, and we're going to talk about the Sonic Mini. That's one of the resin printers that I'll look at. We'll actually start, though, with just some of the things that we've been working on, because I've got a couple of things in over here, and don't know, I wanted to look at those first. So we still have, let's get some stuff out of the way. Still have our Ender 3. The last time that we looked at it, see if I can get it in the picture. It's kind of over here. We had put a camera and Octoprint. There we go. That's better. And Octoprint, which is running, well, it's not running right now, but it's off here in the Raspberry Pi. It's running Octoprint. So we had done that. And why don't we make that start up so you can remember what it's doing. So I gotta basically turn on the Raspberry Pi, which means plugging it in. Now we had changed out this fan. It is quieter, and I have gotten more used to it. It's not as loud, but it's a higher pitch, which to me is almost just as bad, but it is quieter, I will say that. You can maybe hear it. It's quieter overall. It's a higher, like a whiny sound. And we had gone over here. Let's see if I can get the, I don't know how long the Octoprint server is going to take to start up, but let's see if I can find it. Oh, I got to log into it again. Oh, great. I don't know if I remember the password I set for the thing. Oh, I do. Good. All right. So I'm over here logging into Octoprint. So one of the things, oh wow, see, so this will happen a lot. There will be constant updates to plugins, and Octopi itself might have an update here. It looks like to the next version. And so this will happen pretty commonly, regularly. I want to do these later. I did add Octolapse. So remember we have the ability to see the camera here. Over here, well, it's off the screen. You can't just cover it up. And make time lapse. I added Octolapse, which it wasn't terribly hard to do. There's a lot of documentation on how to do it, but it wasn't as simple as just downloading the plugin and it worked. There was more to it than that. A lot of setup between your slicer, which probably isn't currently set up the right way because I've done other things since then, and the Octopi install itself so that it knows when to actually go and take the picture. Oh, I did try it, and so let's see if I have. Yeah, I have this failed one. We can look at it real quick. Can I view it, or I have to download it? Let's see. Close this out of the way. So this is the kind of thing that it can do for us. So it's really short because it failed. It didn't know that it failed. Oh wait, you're not seeing that part. There we go. Let's do it again. So how the time lapse before in just the Octoprint by itself, it has a time lapse thing. That time lapse is not synchronized to anything, whereas this one, it doesn't even look like the print head is moving. It looks like it's going straight up because the timing of when the pictures are taken is coordinated with when the Z axis moves up a layer, and it makes sure that the nozzle is in a certain position. In this case, I put it in the center, but you can put it off to the side or whatever. And so it looks like the print just appears from nowhere. So it's pretty cool, and it was working fine, except it came loose from the bed, and then we had problems. So that was Octolapse. So I did install that. I don't think I want to go through all the installation procedure for that, because it is kind of lengthy and a little bit tedious, and there's probably no way you could actually get two different printers to do exactly the same thing. So it is there, and it is free. It does take a little bit of digging into some documents to figure out exactly what to set up, but in general it works. I did get version 2 camera. I thought I'd try plugging that in and seeing. So right now we've got this image quality right here, And those are all the defaults. There's no actual, like, I didn't go and try to do anything to make that any better or worse. I just plugged it in and let it go. Now, I think, if I remember right, this little holder that I made doesn't actually fit the version 2 camera. So we're just going to plug the version 2 camera in and see. It does cost more for version 2, but maybe $10 more, I think. I don't remember the exact price. See if I can get this bag open. Okay. Let's see. So this is a, I believe, 8 megapixel camera. So it actually looks very similar. It might actually fit in there. Might fit. It's got a little protective thing on it. I can get that off of there. It's got this ribbon associated with it already, but we're going to use our longer one here. Now I may have to reboot the Pi to get this thing to work. We'll see. I don't know if it probably, yeah, it's frozen up. So let's reboot the Pi and see what this camera looks like. And let's see if it fits in this holder that I made. Or, well, I didn't make it, I printed it. Someone else made it. It actually looks like it has the same form factor. Oh, it's so close. I don't think it is. I think that maybe the camera itself is slightly different position. So I think this cover might have to be reprinted because I don't think it's going to be in exactly the same position. So we'll just have to look at the camera. Oh, I got to reload the thing over here. It's reloading Octoprint. Hopefully it's doing that. It's taking a while. All right, and we still have, we'll go back to these. All right, let's see what this, yeah, I think that does look slightly, again, we're talking 5 megapixels to 8 megapixels, so it's not super high density anyway, but I think it is better. And then I need to do some focusing and things like that. But I think that is slightly better. It's still suffering because of the low light, but I actually did get something for that in the mail too. Got this, I think this says Gulf Coast Robotics, also taped up. And here, oh, and some hardware, is power and a little light bar that should mount, whoa, mount right up, way up here. Let's see. So I think, see, it's got, gonna mount right there, and they gave me these. As usual, you get the Allen wrench. I guess that's just kind of standard now to give you another Allen wrench with stuff that's going to have an Allen wrench in it. So, and I like the way that this, so some of these light bars you have to go and plug into your power supply or run power off of your board. This one, I'm going to have to turn the printer off to do it, but it actually intercepts the power back here. I don't know if this is going to show up. Well, this is, of course this is in the way. But it actually plugs, you unplug here and put this in between it, and that's how you power it. Now, you got to route the cord somewhere. We'll have to figure that out. But I'm not going to install this entire thing. I'm just going to see how well it's going to work. So it's going to do something like that. We'll have to figure out where we're going to plug or route these wires so that they're not in our printing path. I'm thinking maybe somewhere over here-ish, back on this side, so that the cable doesn't get caught. Like right now it's on the limit switch, which would not be good, but we could run it under there. And then it did come with, I saw a little adhesive thing where I could mount this somewhere. I don't want to cover up the fan, but maybe right there. And that should get it close enough. It plugs in right here. Has a little bit of that stuff. Now it's stuck to me. Oh, wow. Get off. And then this is just going to mount up here. So I don't want to mount it yet. I just want to plug it in. See what we've got. We will have to figure out this cable because it is kind of short for routing it that way. There's probably some way, and I guess this could actually go wherever you wanted it. I want it up at the top. Let's see, how does our switch work over here? Oh, and it's a dimmable too. So there we can have light. Now it is going to put a shadow down there. But that, I'm looking at the camera. It is better. Still needs some more work on the exposure. There are settings that you can go into in the configuration file for Octoprint and get this camera tuned as for your setup. I'm not going to do that right now either. Now I've got my printer all apart, but we're not looking at that printer today anyway. I will look at this one slightly. I did get the Duet board running on it. I've switched the a BL Touch on from another printer. I haven't got that running yet. I will say there are things I really... Let's turn this one on so you can see. Now it's going to be louder because it's got fans over here that are not quiet fans. It's not terribly loud. But let's look at what this does and why you might want to do it and a lot of reasons you might not want to do it. Number one reason why you might not want to do anything with this Duet. Now I also have the screen. You don't actually have to have the screen. That is separate. The board is actually back in there. It has been quite a lot of work to install it on the software side of things. The hardware is work, but it's just tedious work, like putting new terminal ends on wires so that they'll plug into this board, things like that. A lot of the work in this particular one came because I was trying to mount the board over here versus this printer originally had an entirely separate box that all of the controls were in. The power supply, motherboard, the LCD screen, they were all mounted in this separate box, which I don't like because for one, it takes up more space, and if you ever want to move the printer, you've got to carry that box and the printer, and it's just a pain to do. So a lot of that work came because I was reconfiguring how the printer itself was built. But assuming that you didn't do that part, you could even put one of these boards, these Duet boards, in an Ender 3, like over here. It's pretty tight fit, but it does fit. They make some adapters that you can print to fit in there. But what you get is over here. So you get a control panel. It doesn't run Marlin anymore. It's running a RepRap firmware, and you get, readouts on your temperature, printing. You can home from here, everything. I can click this button and it'll go on home over here. You can kind of see it moving right there. And so that's kind of nice. Octoprint can also do that. The big thing that it can do is actually over here. So these are all the system files, and you can edit. This is basically the firmware. so the configuration files for the firmware. You can edit any of these things on the fly, reset the board, and it has a new configuration. So I can go in here and you can see some G-code commands here. These are all IMs, but this is G-code commands for, this is the configuration file for this thing. And you can set up different whatever you want to change, to tweak. It's going a little bit too far in the X direction for the size of the printer. You can go tweak that. You can tweak literally everything that you could do normally in Marlin when you have to open up Visual Studio, or maybe you have to open up Arduino if you're still running the 8-bit boards, like I was just until a minute ago with putting the SKR in that Ender 3. And there's no SD cards, there's no USB cables. This runs over Wi-Fi. So this particular board that I'm running, let's get out of this before I mess something up. This particular board that's in this machine is a Wi-Fi enabled one, so it's the Duet 2 Wi-Fi. They're a little cheaper right now because there is a Duet 3, but I think the Duet 2s are probably, even though they're the one generation older now, they're still probably 150. I don't know. They're pretty expensive. Let's see. Compared to the other boards that you might have. Let's see. Well, yeah, 155 from Matter Hackers. But that's not the most current board. The most current board is a Duet 3, and it's just way over. Even the 2 is way over. Hey, there's a hot end light LED lighting kit from Printer Mods. Oh, that would be kind of nice. This is in the chat. It connects directly to the carriage, so there would be no shadows. It would be right there under the carriage. That might be kind of nice too. Particularly if your goal is to see the print itself. So here's the Matter Hackers selling the Duet 2 Wi-Fi. There's a lot of 3s. You have to be careful because it's Duet 3D, but that's just the name of the company. The board is the Duet 2, and then there's several versions of that: a Maestro, a Wi-Fi, a Ethernet, all of these different ones. But it looks like these are in the 150 range for the Wi-Fi version. The Ethernet might be, oh no, it's actually more. The Wi-Fi one, well, so I will say I did have a little bit of trouble when I was first starting, because I got the Wi-Fi board not quite like this one. It didn't have a little antenna sticking out right here. It had a separate antenna you had to plug in, and I didn't even think to plug it in, and I could not get the thing to connect to my internet at all until I realized that, because I'd never plugged in the antenna, it had essentially no range. So plugged in the antenna, it was fine. So the downside is kind of expensive compared. If you're just trying to get a 32-bit board, then it's way expensive compared to like the SKR. But if you really are into tweaking and you want a lot of configurability, then it's the way to go for that. But it is not the thing I would do first unless you are already very electronically oriented. There's a lot of reading schematics, not schematics, but pinouts. There's a lot of terminating wires to have maybe you have to rearrange wires or put a different connector on it or whatever. So all these stepper plugins up here technically don't fit from the default connector that comes with these steppers on the Creality machines, but if you just shave off those little tabs on the back side of the connector, then it will fit. So I kind of cheated there a little bit, just shaved those off and plugged them in. So it's a really good board, but it is not for the uninitiated in printing and electronics, because there's a lot of things you have to dig up, and the documentation for here is it is up to date, but it is not I wouldn't say it's easily accessible, because what you'll end up with is you'll be reading along on the documentation and realize that, that was for a board a generation ago and not the one that I'm working on, and now you got to do it this way. And so there's a lot of competing information, and it's hard to track down exactly what you're supposed to do for your board and your printer. It can be done, but there is a lot of little setup stuff. So you don't want to be afraid of digging into writing a little bit of code and electronics, you know, wiring things up. You got to work with wiring the power into here, and there's just a lot going on. And this Tevo Tornado makes it a little bit more complicated because I was trying to repackage how the motherboard was even dealt with. It has a separate solid state relay for the bed. The bed for this Tornado, it's being, you know, a larger bed like this, it takes a long time to heat, so they're running this bed straight off of the mains power. But you have to run through a solid state relay, so it's a little bit more to involve with to get that up and running. So maybe putting one of these on a ender would be a little more direct substitution, but it's really cool if what you're trying to do is tweak every little thing, and it adds, like, I don't know, I think there's like 7 heaters you can run off of here. It's got dual drive for the Z-axis setup. Now by default, these little jumpers here are putting it to just one Z motor, but it's set up for 2 Z motors, so dual Z on the Z-axis. So it's actually got a lot going on. Just be ready for a lot of tinkering to get it to run if you want to use it. All right. I'm going to have to take a little bit of time and clear this off so that we can get our resin printers up here and look at what that's going to be. So the rest of the time we'll look at resin printers and all that. I just wanted to catch up to date on what this was doing. And on that Duet, I do have, I think, yeah, next week I do have it scheduled that we're going to look at the Duet board some more. There's not a lot more to look at, but I will show, like, run through some of what it might do. It doesn't look a lot different from Octoprint on the printing side of things, really. It's on the configuration and all that. Let me move these printers out of the way and put some new printers up here. All right, so now, well, actually I said new printers, but this one printer and this other thing over here that's kind of in the background is actually a cleaning station, so it's not really a printer. All right, so these are, or this, let's see if I can get further back from it. Maybe I need to move it down. Go further away. There we go. Now they're better. You can see them better. So this is a resin printer. So these, here we go, printed this little guy yesterday on this printer. See if how are we going to get to him? Let's see if we can. I don't know how to focus on it so well. Let's see if we can get it to focus. kind of. It was originally green. Like the resin that I used was green. On the question on the Duet board, yeah, the Duet board is running. I just haven't got the BL Touch running on it yet. But I've printed several prints on it, and it works fine. And it is a quiet board and everything. But I haven't got the BL Touch. I want to get the BL Touch running to say that it's kind of done, but I haven't gotten that yet. So I printed this and sprayed a coat of white. Let's see, I sprayed this stuff on it. Sprayed this white primer on it so that you could hopefully see some of the details a little better. Maybe I can zoom this way on him. Get him so you can kind of see the level of detail that you're able to get with one of these resin printers. Now this resin printer that I printed it on is called the Phrozen Sonic Mini. Now there's a Phrozen Sonic Mini 4K, which is even higher resolution, but this is just the Phrozen Sonic Mini. So this is the kind of detail that you can get. You've got these super fine little, I don't know what they are exactly, but things coming off of this guy. A lot of detail in his cloak. There are probably places, I didn't print it at the highest resolution, so there are probably places you might could see layer lines, but I don't see them right now. And it could be that the primer, this is a thin primer, but it still could have covered them in. But super fine detail on these printers. And so this is a solid block. This is resin. So it's kind of a brittle-ish plastic. If I were to drop him, he would probably break something off because it's not too resilient to any kind of breaking like that. I will say though that there are resins that are flexible, and you can mix resins. So you could mix one that's a certain color maybe you wanted, and you can mix in a flex agent or mix some of the flexible resin with that, and then it becomes, depending on how much of the flex you put in there, it becomes less brittle. You might lose a little bit of your detail, maybe a little. I haven't actually measured how much detail you lose by putting flex into the mix, but it does make it where it's not as likely to shatter or something if you drop the thing. So this guy took 3 hours and 45 minutes to print. How does resin compare to PLA? Strength wise, the issue is how brittle it is. PLA is kind of brittle also, but PLA does have some impact resistance. The resin is not so good on if there's any situation where you might have some impact, like this guy dropping, then he would be fine. But all the little, like the sword would probably break. These little tips back here would break. This would probably be fine because it's kind of bulky. But any little finer pieces just don't have any flexibility to them unless you put the flex. Let's see if I have some. I think I do. Well, I think oh yeah. So here's some in this container to try and keep it from making a giant mess. That's the biggest problem with this kind of resin printing, is the giant mess that you can potentially make. So this is a clear flexible resin that you can mix, or you can just print in this, but it's really meant, or I don't know if it's really meant to be mixed with another resin, but that's my goal with it, is to mix it with other resins. So it is strong. It just is so brittle. So I would say that it's strong, but maybe not as tough as PLA. PLA is probably tougher overall. If you're thinking of like drawing the stress strain curve for the material, there's probably more area under that curve for PLA than there is for resin. The way these print is different from anything else. So there's different resin. There's other resin processes also. So there are other processes and printers where you pour. These are all liquid, liquid resins. And these particular ones cure at a 405 nanometer wavelength. There are others that cure with lasers and different. Oh wow, that's got a leak on it. Let me clean that up. So this resin can be caustic, or it's one of those materials. I don't forget the exact word for it, but it's one of those materials that repeated exposure to it actually increases your, instead of getting numb to it, you're in the ultraviolet range. Oh, did we get disconnected? I think we're still back. All right, I think we had a temporary drop in our stream there. So how this works is you pour that resin into, let's open this. You pour that resin into here. So here you can actually see some of the green resin still down in there. Looks like a little piece I gotta dig out. But you can kind of see that it's liquid down in there. So, and also there's a spot, I don't know, we'll have to see what that is. That might be a spot that I'd have to clean out to, you can't see it on the screen, but it might be in the way. Anyway, you pour resin in this vat. Let's get the vat out of the way. All right, and oh, there's some leakies. You want to have some place to put stuff that is coated with resin out of the way in a plastic container or something that so it's not on your surface or off on the side over here. I've got a plastic container that I can put stuff that might have resin on it. You can kind of see some uncured resin leaking around here. We'll try and get that off before I let it sit up and harden. It's because this does cure with UV light, so that's basically sunlight, maybe a UV light itself, or ambient light around you does have some UV also. So this screen is really, how bad does it smell? It actually is, there are different levels. The resin, they have some eco-friendly resins which are less obnoxious smelling, but I would definitely not print and keep all my stuff, resin stuff, out just anywhere. I have a little room over on the side over here where they stay. I would just drug them out so we could look at them. And it probably is dangerous to animals, I would think, because it, let me see if it says has any warnings printed on it. It's got the typical stuff, you know, do not, it has warnings on it that are similar to stuff you would keep under your kitchen counter, you know, cleaners and things like that. So I'm going to say yes, it's probably dangerous to anyone who's not familiar working with it. So you wouldn't want kids around it or animals around it, because it certainly is toxic to drink, I would think. And it even is caustic to touch. So some people get really bad chemical burns just touching it, and others don't. You know, it's kind of an individual response to it. But it is definitely something you want in a clean space. You want gloves, and mine are in a plastic container so that any spills get contained in that container. So it's not something that you just want to play around with. It definitely, you have to plan for this. If you're a messy person, it's not for you. So how this works, inside this box, there's an array of UV lights that are shining upwards. So they're down, I don't want to take anything apart, but inside this box is UV lights shining up. This screen, now this is a monochrome screen, so it's a black and white screen. Most of the printers have color LCD screens. In this case, monochrome is actually way better because you only have to do 2 different colors. Well, basically just on or off, versus having to have these pixels, you know, the red, green, and blue pixels to create a mask. This screen ends up being a mask. So you turn off all the screen where you don't want UV light to shine through. Remember our print bed, or print vat, I guess. hey, there's that part I can get out of there. It's sitting on top here. So this is filled with resin, and if I can find some tweezers, I'll get that out. I may have to wait to get that out. I kind of wanted to run a print though so you could see it, so we'll have to figure that out in a second. So anywhere that's mask off doesn't get cured. Anywhere that there's a hole in the mask, so a picture that on that screen that lets light go through, then that little section will cure. And so it does print layer by layer. The difference in FDM printing layer by layer and this printing layer by layer is that, for one, FDM printing literally spits out plastic, you know, one little drop at a time, versus this guy exposes the entire layer all at the same time. So that entire layer can cure. So if I print this guy, if I print him, and he's going to be hanging from the surface over here, he's going to be hanging down like that. I can print one of these in 3 hours and 40 minutes, or I can print one here, one here, one here, and one here, also all for 3 hours and 40 minutes. Where on FDM printing, I print one on the bed for however long it takes. Let's just say it's 3 hours and 40 minutes again. So I print one. If I want a second copy, then I've added 3 hours and 40 minutes to my print time. Whereas here, since everything's getting exposed at the same time, then it doesn't really matter how many objects I have to print on the little bed. Now this is the bed up here, so it's kind of small on this printer. You know, it's not very big. They certainly make larger ones. But it doesn't matter how many things I put on here. Since every layer is exposed at the same time, it doesn't really add anything to the print time. The print time is totally determined by how many layers it has to print. So how tall is the object. Now, I will say that this particular guy, the sword here, was a separate piece, and I glued it together. So he was really only like that tall, 2 inches tall maybe, and the sword was off to his side. And I think technically this little hand was off also, although that didn't really change the print time. That was just to get the details to work, I guess. Or no, I think this particular model had optional hands. You could put other hands on him. That's why it wasn't on there. All right, and like you asked and I mentioned, it does smell. This resin does have an odor with it, and other resins have more or less odor. This one's kind of in the average odor smell. It is certainly not something that you want to just leave out. They all have some sort of hood over them that kind of contains the smell. And again, I keep mine in a separate room that I can lock off, kind of like a little storage closet out here. And so I can keep them over there away from everything else, because they're just so messy. The print to get this guy going has to be sliced. So here he is. This is and I forgot I printed this base for him. I don't have that over here. But here's how it was in the bed. So I probably couldn't have put another one on here. But you can see all of these little gray spires. They are the support material. So it works in similar way to FDM, where overhangs that just float out in the middle of nowhere have to be supported. So these were mostly automatically generated, and then I went in and added a few and subtracted a few in this box, this slicer. Are there more colors? Yeah, there's all sorts of colors, plus you can dye the colors. So if you have dye in a clear or a white color, you can actually create your own color. But they sell plenty of different colors. Right here beside me, I've got an aqua blue. I've got the original color that this one was, which is this color. So this is the support. This is what he started with, was this green, kind of transparent-y green. But sort of like this. This is the supports. What I do when I print with these things is I print everything, get it on the bed, and this is not cured actually, so you can kind of see it's still a little flexible. So this is not cured. Sort of. I did break it a little bit, but it's just been sitting out. I didn't actually go in and cure this. So print everything and go over to this machine, which if you're going to do any amount of resin printing, I highly recommend. There's other versions of this. You don't have to get this brand, but I highly recommend getting some sort of wash station that's automatic. There's several of them. They all do kind of the same thing these days, but what this is a two-stage little chamber. So one stage with a magnetic spinner in the bottom, and the liquid in here is just isopropyl alcohol. I actually did use the 99%, although I've used the 70% before, and it works okay also. But that's what this is. You can kind of see it's a little bit tinted. Well, maybe you can't tell, but it's a little bit tinted greenish in here. That's because the last parts that I've cleaned in it were these kind of guys that they start out, this green resin. And so I dump it in here. The part, there's a little basket. I didn't go get the basket, but there's a little basket you put all your parts in, and then cover it up, and there's a little control panel along the front where you can select 2, 4, or 6 minute wash times. And I usually do a couple of 2 or 3 or 4 minute wash times. And you push start, the little spinner goes, and it just kind of agitates the part, or it agitates the water, and the parts are sitting in the basket in there, and it washes them clean, so that they aren't dripping, because they're going to come out of this vat, and pretty much no matter how long you let them hang from the little print surface up here, they're going to be hanging from here, right? That little print bed, they're going to be hanging from that. No matter how long you let them hang from there, they're still going to have uncured resin coating them. And so they're going to be all messy. So you get your gloves out. This little plate, you can see the wheel on the top, that you can take that whole plate off of there. You scrape them off of the plate, drop them into your basket, and clean them off. So you can do all that by hand, right? You can have you a bucket of isopropyl alcohol and a toothbrush or whatever, and you can clean them up yourself. It's just, to me, these things are at a price point to where it is okay to buy this, unless you're really just going to print one thing, but then why'd you buy a resin printer in the first place? So I almost consider these a package deal. I have 2 different brands of them, but they actually do make package deals, because there are Anycubic versions of this printer. There's Prusa versions of this printer and wash station. So a lot of the different companies have their own version of a printer and a wash station. And so I would almost certainly get them as a package deal, just because it's so much simpler. So then they're clean, at least. Then you go wash them off. If you leave the isopropyl alcohol on the surface, it will cloud the surface up a little bit, and I don't know, it just creates problems later on. And so then what you do, it's still uncured. It's like this stuff that I just pulled out of here. So it's still uncured, and it's kind of flexible. At that point, I pull all of this off. So all of this, I leave the support materials on until it it's finished its cleaning cycle. Then these really just pull right off of there. You don't really have to do a whole lot of work. It's not like necessarily removing supports from a FDM print where you might have to do a lot of clipping. These just pull away because they've got these tiny little connection points right here, and so they just pull off. Then take this off, put your little stage on here, or however your particular wash station works, and you set him on the stage in whatever orientation you want. And then it's got a cure. So there's a row in the back. You can see all those little white dots. That's a row of UV LEDs. And the turntable turns. And again, you've got 2, 4, 6 minute curing time. So I usually do 6 minutes, and then I flip him over to the other side, because some of it is underneath here. Flip him over and do another 6 minutes. And that's usually enough to cure it to where it's in its final brittle form. If you had a really bulky item, so something that had a lot of mass to it, first off, if you had a lot of mass to that, there we go, to one of these parts, they do have some algorithms that go in, right here, hollow, and you can hollow them out so that you're saving resin. So it's not a solid block of resin, and it is like a shell. So if you're printing something that's really large and massive and you don't need it to be a solid block of resin, then you have some options. Either build it, the model with a hollow inner side, or use a hollow tool here. You do have to make sure there's a drain hole for the liquid resin that's trapped inside there to get out. Anyway, if he's a big solid block, then you probably want to cure it longer. And again, you can put it outside, just let it sit in the sun and cure. I just find this so much simpler because 12 minutes and you're cured, pretty much. And then you can go to whatever phase is next for you, painting or whatever the next thing is. But the slicer, it works pretty much like any other slicer. You move the parts around, you can orient them, you can go in there and if you see a part that you think is unsupported, you can just click that spot and it'll add supports. You can, I think it's alt-click and release supports. And so the slicer is pretty intuitive. And again, most of these supports were auto-generated. It does have some issues sometimes with like this little base right here. I'll have to find where I put it. But it should have a flat bottom on it, right? But since it's being supported at just these little points, let me get it. Since it has those little supports on it and it's not up against the base, you end up with the bottom not being quite as flat as you want it. Now it's resin, so resin is super easy to sand, so you can just sand it flat if you wanted it to really be flat. But there are some issues on like holding dimensional tolerances. So if you're making this and it's got to have exactly down to the 1/10 of a millimeter tolerance, you may have some issues with getting that to work. Let's see, there's a question. Do you still have the same printing issues that you have bridging? You have those types of issues, certainly with overhangs and things like that. Bridging is not an issue because a layer cures all at the same time. So it's not like it has to drag the filament across two different points. But there are similar issues like that. And this being one of them, where flat surfaces are sometimes hard to achieve. You might think that, well, why don't you just, let's remove all the supports. All right. Why don't I just take this part and put it flat on the build surface? Why don't I just put it flat there? And there's a reason why you might not want that, because now oh wait, you're not seeing, there we go. So I removed the supports off of this thing and put it flat on the build plate here. When I go to create this part, this entire surface right here is stuck between the build plate, so the plate up here, which is down at the bottom, it lowers down and prints down here. So it's that circle is stuck between there and the bottom of our vat. Now the bottom of our vat is FEP. It's in the Teflon family, so it's transparent, so you can't. It's completely clear, in fact, and relatively low stick. But this big circle will stick easier on that, or it has the potential to stick on that FEP at the bottom of the vat and not stick to the build plate because it has to pull this entire surface up. So it's tough sometimes to get entirely flat objects like that to stick. You also have a similar thing to elephant's foot, where those first few layers, as they're getting stuck to the actual build plate, you cure them for longer. So your variable, one of your biggest variables anyway, is cure time. So how long does each layer need to be exposed to the UV light to actually cure? And so you can tweak that to get under and over exposure and perfect exposure, so that your parts are as close to the right size as there can be. But those first few layers are usually overexposed to get them to stick to the build plate up here. So if I do that, that's probably going to overexpose them, and these first few layers are actually going to be bigger than they need to be. Now, on these things over here that I'm just going to chop away anyway, it doesn't matter. But if you have a part that's going to sit on the build surface and it's overexposed, that bottom layer is going to be a little bit bigger. In fact, I might have some examples. Let me see. I don't know if you'll be able to see or not. Let's see if I can find a good example. This one's probably as good as you can get. Get that out of the way. So these little knobs were printed straight on the bottom, you know, sitting on the surface like this. So they were sitting on the surface. And you can see, maybe, well, you can certainly see that there's a different color. Focus. Oh, I think I have it on where it won't focus. There we go. Maybe we got to be back here. So see that white ring? You can tell that it's a little bit larger also. I can certainly feel that it's quite a bit larger. It's probably, I don't know, getting close to 0.5 millimeter larger around the perimeter there. And so that's one reason you don't just stick stuff to the build plate, because it's probably going to be larger. And so if it's something that actually needs to interface with another thing or keep that cylindrical size, then it's going to be tough to do that. But when you don't, you end up with things like this one where it's kind of lumpy on the bottom. Maybe if I get that, you can kind of see how it's lumpy on the bottom, because this one was printed with this part being kind of tilted up like that. Let's see, what else can we talk about with these printers? Like I said, they are super messy, so you do need to be very careful. You know, you don't ever touch the resin with your hands if you can get away with it, because some people it doesn't bother right at first, but like I said, repeated exposure to these resins will eventually cause some chemical burn. Some people, the first time they touch it, it actually chemically burns their hands. So you want gloves. You have to assume that everything is going to have resin on it. So you want an area that you can dedicate kind of to have it's something that's going to have resin on it, even if you're the most careful. So maybe put down something to underneath all of this. I use little plastic trays to keep everything in, so that it doesn't get on other parts. But all of that said, if you're looking for high detail, well, going back to even these, I mean, I don't know if you can tell, but there are ridges around the perimeter of this thing that are super tiny, but they are there. Like those ridges are, every one of them is perfectly formed except where I put it on the build plate, and it's it's up against there you can kind of see the ridges, how small they are. Those are not artifacts, those are actual ridges that are in the model. And you can kind of see the detail you can get from these type of things. So you can get super high detail off of these prints in a reasonable amount of time. And I didn't even talk about this, they're not that expensive. So I looked just to see. Here's this printer. Right now, apparently it's on sale because there's a new version. So this is the printer that this guy was printed on, this Phrozen Sonic Mini UV, blah, blah, blah. There is their newer version right here, and obviously it's twice as the cost, but it's 4K. So the screen that screen that's acting like the mask between the UV and the resin is a 4K screen on this one. It has the same print size and everything. It has a couple of upgrades also. So one thing, this printer that I'm using, actually, maybe they've already upgraded this. Let's see if I can tell. Yeah, I think they have. So the one that I have actually has a plastic tray in it. And it looks like they have switched over to an aluminum tray here. Let's see if it has any details. Thought it might tell me the minimum layer. Oh, there it is. The minimum layer can go down to 0.1 millimeters. So I mean that's this guy is not at that. This guy is I think 20 mil. Well, let's see. Got it right here. What layer height are we at? Where are the property settings? We're at 0.5 millimeter layer. So one of the thinner layers, but not as thin as it can possibly go. So 0.05. But you can print at thicker layers if you wanted to speed it up. But this is at 0.05 millimeters, which is pretty thin. And then, like I was saying, they do make larger ones. So here's a little bit larger printer, and that's the 4K. And then they make some much larger ones. Actually, apparently I bought this in February 27, 2020. So it's about a year old. I will say, speaking of the age of these, the screen itself is considered a consumable, but the monochrome screens, I think they have a lifetime of like 1,000 print hours or something like that. So it's going to be a long time unless you're just printing continuously. So they're not terribly expensive. The resin itself, I guess we should look at the resin. See what the going rate for that is these days. See if we can. What's a good brand of resin? Well, let's just look at the Anycubic resin. Oh, it lost. Well, we'll do it this way. Cubic resin. Oh wow, that's actually really cheap. This must be a small bottle though. Yeah, this is the smaller 500 gram. This one is a liter. Most of the time I get the liter bottles. So a liter of resin is the cost of a nice roll of filament. So one of the much nicer rollers of filament. So it is a little bit more expensive, but a liter of resin, this guy, let's see if I slice it, how much resin it's going to take. Takes a little longer to slice sometimes because it is doing 0.05 millimeter layer heights. But we're almost there. All right. Oh, because I don't have the supports under there, it's only 3-hour print. But 24 milliliters. So at a typical price for the Anycubic green resin that I was using, that's 72 cents. So slightly more expensive than a print would be, like a filament-based print. But still, we're less than $1 for this guy. 3 hours, which if you were to try and print this particular guy at a high resolution on a FDM printer, it's going to be longer than 3 hours. And 24 milliliters out of my 1 liter bottle, that's essentially nothing. So one $40 bottle of the resin is going to last you a long time. All right. I don't think I want to. Let's see. Do I want to? Yeah. Why don't we start up? I don't want to wait for a print to finish necessarily, but let's start up just so you can get an idea for what. Let's not do this one. Actually, let's do that. This little guy. So let's tilt it a little bit. Now, actually, let's not do this one because it has this long spire on it. Well, I don't know. We'll do it. We just won't wait for it to finish. All right, I'm going to tilt it a little bit, and I'm just going to do the auto support. Just kind of move it to the middle. There's the supports. We could make them, there are a lot of settings in here. We could make them more dense and everything. I just left them all at default. Let's go back. Let's slice this thing. I got to plug in the printer. Let's see if I can figure out which one. I think this one is it. Oh, and there was that little piece of debris I got to get out of it. Now, there's very little resin left in here, but I think it's enough. Well, we're not even trying to really print this. Let me find my tweezers. So I think when I was scraping off the previous one, some of the parts fell in the vat here. I don't need them in there. Let's see. All right, I think that's it. All right, let's cover it back up. And I've got a little SD card. This one, they do use SD cards. Actually, this one uses USB. So let's save this. It says it's going to take an hour and 22 minutes to print this thing. So you don't gain a lot on the speed unless you're actually printing the whole bed full of stuff. Like I can fill this entire bed up with, it's probably 4 or 5 copies of this thing, and it would still take an hour and 22 minutes. Because it's all dependent on how high this thing has to reach. All right, let's open the folder and eject that drive. I've been having a lot of problems lately with these SD card drives being corrupted. So I've tried to be more careful about actually ejecting the drives. All right, get that over there and get down here. All right, so there's back there's a big button that says print, and then it gives me a tiny little preview. This is it, and it gives me a little preview. You can barely see it, but it's a little preview of what it's going to print, and there's a button that says go. And what's happening now is this is lowering. You know what? I didn't actually set this back right. Let's pause. It may, oh shoot, I may have to shut it down for a second. Let's see. I'm worried if it's going to clear the vat or not, because in fact, I don't think it is. This goes the other way. There we go. That was on backwards. All right. So it's got to go through its boot up again. Print. Base. Go. All right. There we go. There is a tiny bit of setup when you first start these. Like you have to get the correct distance between this plate that's lowering and the sheet that's holding all of the resin. But all that is putting a sheet of paper down and basically leveling it. There's some screws on each side to let you level it. So that's kind of leveling the bed. You don't have to really do it very often. I've never had to do it more than, I don't know, once a month maybe. And that's only if I bang something around. So you can kind of see it's showing what it's exposing. And these first few layers, like I said, are going to be exposed more than the future layers. One of the advantages of the monochrome screens is that a cure time for a layer, a typical layer, not a base layer, but a typical layer is 2 to 3 seconds per layer. So it can be super fast once it gets to those regular layers. These first few layers have a cure time. Let's see. The bottom, yeah, so the bottom layers, which it has 6 of, we're over here now, are at 25 seconds. So it's going to do those first few layers kind of slow, but it wants them to stick to the build plate and not to the bottom of the print resin vat. But after that, it's 2 seconds per layer of exposure time, and then the light is off for 7 seconds to kind of let everything settle, and then it pulls the plate up to retract it, and then it does a new layer. So in a second, we'll see it pull up. You might even hear it pop. I heard it. I don't know if you could hear it or not, but it rose. And then what it's doing is it has to pull the print off of that bottom FEP layer that's in the vat. And what you want it to do is pull up and then a little pop sound, kind of like you tapped on a drum. And that is telling you that it released from the FEP and it stuck to the build plate, which is what you want to happen. So I can hear that every time. I don't know if it picks up on camera because it's a faint little, like it really is just a little tap. Kind of just a little tap. I wish I knew what layer it was on so you could see some of the, oh, it's on layer 5. There are, in that little tiny thing, there are 535 layers in just that. So that's how thin the layers are. And why it's so hard to see the layer lines in them. All right, let's let it do, this is the last big slow layer, and then it should do some of the faster layers. They're still not going to be super fast because the exposure time is 2 seconds, and then there's a 7-second dwell time of just letting the resin sit there, and then the little lift and lower, and then a new exposure. But it does that over and over and over again. This printer, and I assume a lot of them have this feature also, it has a pause button because you can't actually see what's going on. You're relying on hearing. All right, now it's doing the faster layers. And just kind of hoping that stuff is stuck. But this one you can pause, it'll raise the bed up, and then you can actually see if stuff's stuck the way you wanted it to. Because there are print failures just like any other printer. But I like these as long as you're careful with, you know, keeping them contained. The resin itself is just nasty to deal with. So that's why I recommend the wash station so that you have as little interaction with the uncured resin as possible. And just wear gloves whenever you're dealing with the resin or anything like that. It is possible to recuperate this resin so you can pour it back into the bottle. The bottles are all, you know, they're all kind of this opaque material because they would cure with exposure to light. So you'd have to keep care of that. But once they're going, like I don't smell anything here. Some people probably could smell this. When I have the lid off, yeah, you can smell that. But even so, I keep these away in a little room just because they're potential for mess. You know, anything could come along and create a giant mess with this resin. But you get some really good results, and you can do some really cool things that are just either impossible or really, really hard to do with the FDM printers. You can get good quality FDM prints. In fact, let me show you. I think I've showed you these already, but let me show you these. So these are some guys that I printed, and just to kind of compare what resin versus FDM print is going to be. So this guy, let's see if I can get him somewhere where we can look at them without having to hold them all the time. I can't get the camera Oh, there we go. That's good. All right. So the dwarf guy is a resin print, and the orc guy is a FDM print on the Ender 3. So it's just plain Ender 3. No, at that time there were no upgrades on it at all. I might have added one upgrade, which here, this kind of thing. I might have had a new Bowden tube on it, but other than that, stock Ender 3. So Ender 3, and this guy came off of this printer. So you can get really good details. I mean, you can see, if you start looking close, you can see some layer lines. Maybe if I can get it to focus on them, I don't know if it'll focus very easily on him. So you can, in his shoulder up here, you can kind of see some layer lines, but they're pretty small. But compared to this guy, there's no layer lines here. So you can get really good prints off of just a FDM printer, a regular old Ender 3. The difference is this guy is one of, I think I printed 6 at the same time, all with that quality, and this guy was just by himself. And the time it took to print this was longer than the time it took to print all 6 of these guys. So that is different. In these particular ones, I don't think either one is particularly brittle. This one's PLA, and you know, you could probably snap that off of there if you wanted to. On here, the way the model's made, there's not really any parts that are just going to break. Actually, looks like I did break off a tiny piece of hair right there because it's missing. But you can get good quality, high detail prints off of either one. It just is, are you willing to wait for the FDM to print it, and you're okay with having a little bit of layer line issues even at the high resolution printing on FDM. You can kind of hear our print going. Now it's going to go for another hour, so I don't want to sit here and wait for it to go. But that's kind of an intro to resin printing. It is accessible. It's not something you can do unless you have a place to keep these printers and all the resin mess, because that's the biggest issue, is the resin itself is so messy, and some of it is really smelly, and some of it, all of it, is caustic. I have not tried the eco-friendly water washable resins, but they do make them. Let's see if I can see anything about that. So doesn't look any more expensive necessarily. You want to make sure that you have the 405 nanometer if you're doing these UV printers. Let's see, how much do you have to alter your slicer settings when you're trying? So to do the FDM printing of the high resolution, the key to it, for these kind of, for getting something like this guy, is just to take and make all layers top layers. So let me show you. And that's really the only thing you have to do. There are a lot of little tweaks, like getting your retraction set just right, and maybe even putting a smaller nozzle, like go down to a 0.3 millimeter nozzle. I didn't do that, but you can. That will certainly give you a better resolution. Finding the minimum resolution that your printer is really good at, which is usually around 0.1 millimeters, maybe 0.12 millimeters. But the trick to it is, once Cura loads up, it's taking its time, is to just print everything as top layers. Because the slicer, when it's doing top layers, is for one thing, it's printing slower, and it's taking its time to infill everything, and it's just doing a better job of creating everything as a solid layer. So it's not necessarily that you're wanting that for the strength, but the fact that it is. Let's see if I can find this Warcaster guy. This is him. No, that's his hand. All right, let's put that in there. And let's put, there's a sword. Let's find, this must be him. All right, we'll put him in there. All right, so if I were going to print this guy, let's just try to set him up. I don't want to worry with this hand right now. You probably are going to have to figure out supports. So generally what I want to do is normally with something like this, you want the front is the part that you want to maintain most details. So I might go and just see what the supports look like. But first of all, on the top layers right here, I just use that. I just set that to some giant number like 1,000. You know, something that I know don't have that many layers. And then I think I printed mine at 0.12. 0.1 wasn't working for me, so I think I did 0.12 millimeters. Infill at this point doesn't actually matter because I've got everything as a top solid layer anyway. And then let's go ahead and generate support everywhere and just see what it does with it. Now it's going to take a while to slice, so you do have to realize that it might take longer than normal to slice because it's thinner layers and there's a lot of detail in these guys. There are some optional support types that I'll look at in a second. All right, so 7 hours to print this guy. But that's kind of what you're looking at when you're trying to do these high details on FDM. Let's see what the supports look like though. Yeah, so see how it put supports, it's just a big yellow blob probably on the screen, but it put supports kind of on the front here. Oh, and then in the chat, there's a manual support plugin for Cura. I haven't used that, so that's something to try out. But what I usually do if I'm trying to do one of these is I tilt them back just a little bit. Where's the back one? There it is. Come on. There it goes. So just a little bit to try and make it where the supports aren't showing up on the front. So if I have supports, then they're on the back. And in the supports, there's also an experimental feature. Well, and it's not even no, it's not experimental anymore. So, or at least not on mine. In the support, where did it go? Support structure, which you may not have all these options enabled. You might have to go in the little settings wheel and enable them. But this tree support, it's kind of good for these type of models, but it takes a lot of processing power. And this, I don't know how long this is going to take to slice. And I wouldn't try tree supports before you own something like this. I would try it on something else first, just to see if your printer was going to print them well or not. And it takes a long time to create them, but it creates kind of vines around your printer. We'll have to look at that manual support plugin for Cura. There are other slicers that have manual supports built into them, like Simplify 3D, but that's not a free slicer. Prusa has some paint-on supports in the, I don't know if it's in the most current release, stable release, but it's in one of their betas at least. But I haven't looked at this Cura manual supports. I wanted to, maybe it'll finish in a reasonable amount of time here. Hey, it actually made it less, 6 hours and 46 minutes. But look at these supports. See how it's kind of got all these vine-looking things growing up around it. They are much easier to remove typically, and to me, they just work better for models like this. I still would probably try to rotate this guy back a little bit more so that I didn't hit anything on the front. I'd rather have to remove support from the back of the model and deal with that versus having little support location, anchors on the front of the model. But if the manual support, like what I would do with manual support, is I would remove these front things over here. There is, there is a way to do that. Hold on. Let's go back. Let's see, where's that? This little block down here, support blockers. So if there's a spot that you know that it doesn't really need support on it, you can actually put these little support blockers in place, and it will not connect supports to that. So that's one way to, you know, you can kind of, I don't want any supports on the front. I'm just going to let it droop or whatever. I'll fix it later, or I'm just okay that it's not going to create any problems. And then when you slice, it just won't put supports on that location. At least that's the way it used to work. Although that looks like it's erasing. I thought, well, we'll see. We'll see. They might have changed something on me. It's actually taking longer to slice. Well, if this doesn't speed up, then we'll call it a day. But it is moving at least. It just takes more and more. The more things you're asking it to do, it takes more and more processing power. And I still have the tree supports on. I would try the tree supports. I don't know if I'd try the first time I tried them on a 7-hour print, just because it does take a little bit of tweaking on some of these settings over here to get it to actually work. Oh, here we go. Well, it still wanted to put some on the front here. It just kind of still has this one little arm. I would probably need to put a support blocker over there because I wouldn't want that arm. Anyway, there's a lot you can do with supports, but the key to printing high detail, in my opinion, is actually this right here. Printing everything as a top layer. It does make it take incredibly long to do, but it just is better. It seems you get better results when the actual print is done by making everything a top layer. And then figuring out what your layer height minimum kind of is. For me, in that Ender 3, 0.12 is about as low as I've ever been able to go without changing the nozzle. There are much small. There's 0.2 millimeter nozzles if you really want to change things up and get high detail out of an FDM printer. I would not go to 0.2 first because that's so finicky to get it to extrude cleanly. But you could go to a 0.3 millimeter nozzle, which you're running a 0.4 right now, and 0.3 is probably going to be similar enough. Obviously, you have to change your settings here on the line width. So, you know, your line width for all of these things would have to drop down to 0.3 because you're using a 0.3 nozzle. Or at least it'd be better to drop them down. All right. Let's go back over here and see what our print is doing. So what we want, I'm going to pause it, and what we want is we want all the stuff that we printed. It looks like we've just started printing the base. All this up until now had been all those supports. I'm going to pause it, and we'll see if we can see what's going on. So hopefully there's stuff stuck to the bottom of this. And there is. It actually looks like it's working well, but I don't know if I don't know how I'm gonna get you down there to see it. Where? I have to move down here. There it is. So there's our part stuck to the build surface. So that's what you're aiming for with these prints, is getting that to start. And it's already smelling, so I'm gonna put it back and let it go back to work. I'll let it finish now that it's looks like it's printing well and it's stuck well. That first little bit getting stuck to the build surface is usually the failure point, unless you forgot something somewhere. You know, you forgot a support and it's got a part that's floating free in space. That can create problems, but looks like we're probably good here. All right, I'm looking at this this resin right here. I'm kind of liking this resin. I might try some of that. It is water washable and I like that color, so we might try that. See how that works. Not all the resins are transparent. Some are transparent. I have that one that's clear. Now, don't think you're going to get an optically clear print. It'll look great, like it's perfectly clear, but then over time, it's still going to continue to yellow over time or get cloudy or something. So it's going to be tough to get a actually really clear print cured. There's some post-processing you can do, spray it with some clear, sand it and polish it, and it can look kind of optically clear, but don't expect to print something and it be optically clear. If you want to print like lenses or something like that, it's going to be kind of tough. But I might try some of this. It looks really nice. All right. I think that's enough for today. I'm going to go over to Zoom if anybody has any questions over there. And we'll be back Thursday. Thursday, I have on the list that we're going to do photogrammetry. So this is where you take a bunch of pictures and create a 3D model from it. Or you let the software create 3D models from it. And we're going to look at how that might work and some of the ways that you can create geometry without modeling it in SolidWorks or Tinkercad or Fusion 360 or anything like that. So that's for Thursday. All right, I will see you all then.